do that as well on Wednesday. I also would highly suggest that you guys try to go to the tutoring center during your lunch periods. Every teacher in there can do these math problems. So I believe that you guys are going to be in good hands if you guys can make it to that tutoring center. But let's run down to the worksheet that we have today. So there's no notes. This is the worksheet packet. This is the quiz review that we have. There are 20 questions in here. Like I said, I'm going to go through every single one of them because, again, if you can grab these concepts behind them, I think we should be good to go for the quiz for tomorrow. It's all just similar shapes, similar triangles, just applications in the real world. So many of these, again, are going to be where we take a triangular shape and we try to divide it into two triangles, and we try to draw two separate triangles. Some of them are given to us, some of them we're going to have to create ourselves. So in this particular instance, BE is parallel to CD. So again, we see the two triangles that we have here. AB is going to be 10, BC is 2, and CD is 18. If I was going to separate these two triangles, I have one triangle here in yellow. I have another triangle, larger one here in pink. If we were going to just take these guys and separate them out a little bit, sometimes this is nice to see. So in yellow, I have a side 10, a side X that I probably don't know for BE. I was going to name this ABE. This one up top is named ACD. And I have a side length of 12 when you add those together, and 10. If I was going to look at these, I would probably set up a small to large ratio. Again, we're comparing some sides. You can see that the 10 and the 12 are going to correspond with each other. So I have a 10 for the small, 12 for the large, X for the small, 10 for the large. Oh, that is definitely an 18, not a 10. We're going to cross multiply these, solve from here. 10 times 8 is going to be 180 times 12x. When we divide these out, I am going to use a calculator on the side real quick. 180 divided by 12, you might have just heard my cat there. We have an x value of 15. My cat is dying for food right now, I guess. Second triangles that we have here. Again, we see and recognize that we have two triangles. We have a small triangle right here. We have a larger triangle. And if we separated these two out individually, we could go ahead and look at their measurements. On the small triangle, I have an X and an 8. On the larger triangle, I have a 20 and a 12. Again, similarly to the last time that we did this, I probably have a ratio of the small triangle to the large triangle. Sides that match up look like the 8 and the 12. So I have 8 from the small, 12 from the large, X from the small, 20 from the large. Cross multiply. 8 times 20 should be 160 equals 12x. If we do this, we should end up with 13.3 repeated for that last side there. So a common theme you can see throughout this process is triangles. We're going to have similar triangles over and over and over and over. Again here, small triangle, large triangle. Separate them a little bit. Numbers, larger triangle has a 15, smaller triangle has a 7, larger triangle has a 16. Now here's one of the tricky parts that pops up here. This measurement that we're missing right here, we have to recognize that this is actually the entire length of this whole entire side minus what we have here. And so the idea behind this is you could recognize this as 16 minus x, the whole minus the part. Small compared to large. The sides that do correspond with each other, according to the small triangle, I have a 7 and a 15 from the pink. Small triangle, I have a 16 minus x and a 16 up top. When you cross multiply these, just be careful. The first one isn't too terrible. You do 7 times 16, you get 112. But I always write this one out as 15 times this quantity that you see right here. Again, that's something that's really easy to accidentally mess up. But after we distribute this, 112 equals 240 minus 15x. I'm going to subtract 240, subtract 240. I should get 128, or negative 128 equals negative 15x. And again, if you divide these, you're not going to get a perfect number out of this. This is actually pretty not so fun number of 8.53 repeated, but that's the side that we end up with as we jump through there. So again, they're just asking us to solve for x, and we got that. These next ones are a little bit of applications. Usually with these, you see something that is vertical and something that is casting a completely horizontal shadow of some sort. It could be trees, people, buildings being vertical, but usually the shadows are always what we see here. So it says that I have a tree that we don't know how tall this sucker is, but we do know that it casts a 24-foot shadow. I also know that I have a yardstick. Yardsticks are 3 feet tall. That thing is going to cast a 2-foot shadow. We have ourselves here some similar triangles and shapes. So I'm just going to label this as the left side and right side. And if we compare these two together, left to right, numbers that match up, I have a 2 from the left and a 24 from the right, one ratio that has just numbers, a 3 from the left, an x from the right, cross multiply, 2x equals 24 times 3 is 72, I believe. X should be 36. Congratulations, your tree is 36 feet tall. For number 5, again, you see something along the lines of this with like leaning against things. You have, again, something vertical, but this time instead of having a shadow that's horizontal on the ground, we're kind of talking about a ladder oftentimes, or a piece of wood that is leaning up against the wall. That creates this horizontal line figure that we're seeing here. But we have a ladder that is, the foot of a ladder is 1.2 meters from the fence. That is 1.8 feet high. From those statistics, I see the fence is right here. How far my ladder is from that fence, we see there. It also comes through and says the ladder touches and rests against another building that we don't know how tall it is, but we do know that that building is 1.8 meters away from that fence. So you end up with the two separate shapes one more time. I'm going to highlight them. If we separate and draw some values here, this pink is an x, 1.8 over here, 1.2 for the small one, and then the larger one, again, we have to add those two values together. That should give me a grand total of 3. If we once again go from the smallest to the largest, on the smalls, I want numbers only, so I have a 1.2 compared to a 3. I also have a 1.8 compared to an x. Cross multiply. We're hopefully getting really good at this because we're doing it just about every problem that we see. 1.2x. I need a calculator for this one real quick of 5.4. Once you divide those out, you should get an answer of 4.5. So it does say draw a diagram, which they give it to us, determine the height of the building. The height of the building should be 4.5 meters, not feet. Next up, again, producing a nice little picture for us. You can see here in this image, they do give us some angles that are going to be congruent here. You can also assume that these vertical angles are going to create, or these vertical segments are going to create 90-degree angles. So we have two similar triangles here. What we are trying to find out, it looks like, is the value of the x that we have here. So if you're going to match up these triangles, just be a little bit careful. The sides that actually match up, this vertical side and this vertical side, I think are clear to see, but it's actually the two bottom sides that also are going to match up here as well. Again, if I was going to go from a small triangle to a large triangle, from the small triangle, the measurements that I see, I have one that is 7.5, larger triangle is 45, small triangle 6, large triangle x, cross multiply, 7.5x should give me 270. After I divide those out, you do get a nice answer of just 36 for that missing x value. Now we start seeing slightly different problems. Whenever, I think I've tried to show this to you guys earlier, whenever we see this kind of a symbol where we say there's a ratio of 8 to 10 to 12, I always try to mention to you guys that you need an x value for this. So they're saying, hey, I've got myself a triangle. Again, they didn't tell you what kind of triangle, they didn't tell you the size, they didn't tell you the name of the triangle, but what they are telling you in these instances, they're saying, hey, I've got one corner, one angle that should be 8x, one angle that should be 10x, and one angle that should be 12x. Our previous knowledge from triangles tells us that if we add all of these measurements together, we should get 180 degrees. I do believe that should give me 30x equals 180. Your x value should just be 6 in this instance. It does ask you what the angle measures are, so we do have to plug these in to find the last little angle measurements that we need. It looks like 6 times 10 is 60, 12 times 6 is 72, and 8 times 6 is 48. So those would be the three angle measurements that we have, all adding up to 180. Next up, we have the perimeter of shapes here. So we have a rectangle. Let's start off by drawing the rectangle. They tell us that the perimeter is going to be 54. And again, we see this ratio symbol here, where it says the ratio of the width to the length. It doesn't really matter which one you put where, but you just want to make sure you stay consistent again. So I look at this as the length. So I think one thing I should point out here is that the order that they mention these matters. So the width should be the first number, the length should be the second number here. That kind of gets some people, because I personally label this as length and width this way. So if you look at that, I should have a 7x here and a 2x here. Again, just because we see this, we are once again going to use an x value for these. Don't forget though that opposite sides are going to be congruent. So I do have that 7x here and that 2x here as well. Together, if I added all four of those sides, I should get 54. Well, let's add them all together and see what happens. 7x plus 7x plus 2x plus 2x should equal 54. That is a whopping 18 x's should be 54. And I believe x should be a value of 3 here. It does probably ask what are the measures of each of the sides. So again, you just have to plug and chug some values in here. This should be 21 for this side. This side should be 6. Add those together over and over, you should get 54 for the perimeter all the way around. Next up, quadrilaterals. They don't tell us too much besides just the names of them, so I'm going to draw a quadrilateral. Like, make it easy for yourselves, guys. If they don't specify, just draw two shapes that are very easy to draw. In this case, I like to draw rectangles. When they tell you, in this sense, how like the names of these, name them in the exact same order. What I mean by that is I'm going to follow the pathway of this to name them. When I do that, I'm going to follow the same exact pathway to name this second one as well. G, E, O, M, A, T, R, Y. Again, you can verify that things are going to match up. G, E, and A, T should match up the same way we used to do our triangles as well. From here, we throw some numbers in here. It looks like EO is 18, TR is 24, and they are asking what is the ratio of their areas. Remember this statistic. The ratio of sides is exactly the same thing as the ratio of the perimeters. And what I mean by that is if you match up one side with one side, that ratio is going to be exactly the same if you match up all the sides with all the sides. That ratio is consistent. But there's another ratio that we have to mention, and that is this. When you have the ratio of your sides, or you can think of it also as the perimeter, it doesn't matter which one you use here, if you take those and square them, you will actually end up with the ratio of the areas of those two. This is a huge one for you guys to remember. I can't emphasize enough. This is one of the main topics that we learned so far in this unit, was that relationship between the ratio of the sides and the perimeter to the ratio of the area. Vice versa, if you wanted to do the other way as well, it would be that you would have to take the square root of this. And I guess I can write this down for you real fast. So if you were given, for instance, the ratio of the area, you would need to take the square root of that to find what the ratio of the sides / perimeter. And that's just your normal math. If we were going to look at like solving this one right here for the ratio of the sides perimeters, we would have to get rid of this little exponent right here. And the only way to do that is by taking that square root. Both of these equations are realistically the same exact thing. One is just solved for one variable where the other one is separate. So from this, it looks like they were giving me two sides. So if I was going to go from the left side to the right side, and that's the ratio I'm going to use, I know I was given a ratio of the sides of 18 to 24. We do need to simplify that though. Both of those values there are divisible by 6. I believe this is just 3/4 is the ratio that I'm looking for. Well, now they're saying, well, what's the ratio of their areas? Take that 3/4, that's the ratio of their sides, that's also technically the ratio of the perimeters, square it, we end up with a ratio of 9 to 16. That is what they're looking for, and they're only asking for the ratio of their sides, not necessarily what the areas are, the ratio of the areas. They're not asking what each individual area is. Eventually, over time, like we will get to those problems, but this first one's kind of easing into it. 10, I got another gym. It looks like it's a rectangular shape. 96 feet long, 75 feet wide. We're going to a blueprint, and this one is one where we're kind of thinking of two separate shapes here, where one is a real life size shape, and the other one is kind of a scale shape. And so one's typically going to be smaller in the sense that we have here, but we don't know what these things are. Oftentimes I'll put like an X and a Y here because I just don't know what those scale factors are going to be. But what they do tell us is they say, well, you know what, that one gym, the length of it is actually going to be 5.5. So if I come back and erase this one, I know this is just 5.5. They're asking how long the gym is now. So they're asking, or I'm sorry, how wide it is. They're asking for this Y value. We can actually set this up relatively nicely. I have two corresponding sides on the bottom here. I have two corresponding sides on the right. If I compared these from the left shape to the right shape, I end up with a 96 over 5.5 and a 75 over Y. Big numbers here, but let's cross multiply. 96Y, and I'm going to have to, again, bust out the calculator. 5.5 times 75 should give me 412.5. Divide that by 96 is not a nice number. I end up with 4.29. I'm going to write this whole thing out. 6875. It does say to the nearest tenth. So again, what that means is we take the first two digits, and then depending on what that next digit is, if that is a 5 or above, we round it up. That definitely looks like it. So I think the value we are looking for is actually going to be 4.3 inches for that one. Scale maps. This one, they don't really give you any images on this one, so you kind of have to either think of it over yourself, or we can kind of, again, just mentally picture what this is going to look like. Scale map of Illinois is a 1 inch to 4 miles. They're actually giving you the units of what you guys are comparing right here. Typically, when they do that, I write that down as my initial ratio right away. I have inches to miles. You could think of this as two different shapes, though, like a real life thing in miles, and then a map is usually inches, something like that. So let's see what they have here for the ratios. They're instantly telling me what the first one is. I have a ratio of 1 inch to 40 miles. They're then telling you you're visiting your sister at ISU, great college, no biggie. But at ISU, they're saying the distance on the map is 3.14 or 3.25 inches. Just make sure that you rewrite that as a decimal itself. How many miles is that? Not 100% sure, but that is something we can solve for. Cross, multiply. 1x equals, more calculators, 130. Congratulations, I think that is actually the answer right there, since we have our single x value by itself. But 130 miles is what we're going to have. James and Jesse are standing next to each other. James, so this is another one where I look at this, I'm a big picture guy. Let's say this is James, he's standing here. Now, they don't necessarily need to be standing next to each other. I want you to think of them as just two separate people, two separate triangles that we see here. So James said, let's call this James. Let's call this Jesse. James casts himself a 12-foot shadow. Jesse's is 9. They're also saying that Jesse is 5 feet tall. How tall is James going to be? We again have our similar sides here. Vertical sides are going to match up. The horizontal bases or those shadows are also going to match up. So if I go James compared to Jesse, a measurement from James, I like to start with the numbers. 12 compared to 9. I also have x compared to 5. You guys are getting this theme pretty well. 60 equals 9x. You will end up with a decimal for this one. It is 6.6 repeated over and over. So James is 6 2/3 feet tall, aka 6 8 inches. Next up, more of these ratios that we see here. The pen just died, ladies and gentlemen, with the pulp. That stopped the recording, but we're going to go old school. I got my old stylus here. Oh, no, okay. Disconnect. Hey, we're back in business. So anytime you guys see something like this, remember that we have to introduce x's. Handwriting will get a little worse here, guys. I'm sorry. But in this one, they've got a ratio of isosceles triangles. And again, they're telling us what the perimeter of some of these things are. So if the ratio of the sides of the perimeters is 4 to 4 to 7, an isosceles triangle, we have two sides that are the same. Introduce your x's. 4x, 4x, and 7x, because we know that those two sides do have to be the same. They're telling you the perimeter is 52.5. So they're telling you, hey, if I add 4x, oh, this style is not good. I have 4x plus 4x plus 7x. I should get a grand total of 52.5. That is 15 x's is equal to 52.5. Dust that calculator out. 52.5 divided by 15. Nice answer for us here. I just end up with an answer of 3.5. More scales that we see here, and typically, again, you see something in real life, something down to something else that you see. The dimensions of the great room of a castle, let's just draw this one out since they're telling us it's a rectangle. I have one that is 50 feet wide, 50 feet long, 40 feet wide, whatever you want to use there. She wants the length to be 4 more than the width of the scale. She wants the length to be 4 more than the width of the scale. What are the dimensions of the great room in the scale model? So in this one, oops, sorry guys. So in this one, we have a scale model. Again, if I was going to do this, I do lengths and widths like this. I just want to make sure that I did this right. Yep, did that perfectly. So if we look at this, it says, I don't know what either of these are necessarily, but I do want the length to be 4 more than the width itself. So whatever the width is, x, I want the length to be whatever the width is plus 4. That's kind of a tough one to come up with there. But that sentence right there is really, really the big issue there. You want the length to be 4 more than the width itself. I do have corresponding sides here. Although it seems a little weird, I have only x's in this problem, so it's not going to be too bad. Let's do a left side and a right side. If I compare left to right, left side, I've got one that is 50. Right side, I've got one that is x plus 4. Left side, I've got a 40, and right side is just an x. Cross multiply 50 x's, and again, I write this one out every single time. Distribute that. Subtract your 40 x's from both sides. I'm just going to rewrite this up here for some room. You end up with 10x equals 160, and your x value should just be 16 at the end. So it says, what are the dimensions? Don't forget to actually answer the question. If I have one that is 16 plus 4, I believe that should make this a value of 20. I believe that should make this just the normal x value that I have of 16. So that's the only weird one that you'll probably see on here, where you have to like kind of use the same letter twice. I wouldn't anticipate too much of that going forwards for you guys. So don't worry too much about that problem if you don't understand it. Once again, real cities, scale maps, they give you an initial ratio as well. So let's do, if you want to just see this in a different way, we can do one that'll be the city compared to the map. That's going to be the initial ratio. I'm just trying to give you guys some other options of how you look at this. They're telling me that the map is 1 inch, the city is 30 miles. They're saying that Chicago and Peoria are 165 miles. That is on the map. How many inches should those be apart on the scale? Let's cross multiply and see what happens. I think actually, oh, now that I looked at it, I put those in the wrong places. These x's should be in the opposite places. That was my fault. So again, the reason for that, the miles is part of the real life scenario or the cities that we're looking at. So that should be 165 at the top. We should have x at the bottom there. Cross multiply. You end up with 30x equals 165. After you divide, you don't get a perfect number, but you do not get a terrible number. It should just be 5.5 inches apart from one another. Now going forwards, it looks like we've got more shapes. So 2 heptagons, 7-sided figures, have corresponding sides and ratios, or have corresponding side ratios of 3 to 7. Don't forget the ratio of your perimeters and the ratio of your sides. They are exactly the same. So you actually know what the ratio of the perimeters is. It is 3 to 7. That is the correct answer. The ratio of their areas, the exact same ratio. And sometimes I like to write these as fractions. So if I write like 3/7 like this, a little bit easier to see that you can square them. That means that the ratio of their areas should be 9 to 49. Again, big takeaway from this whole entire process that you're looking at. Backwards, they're telling us that I have the ratio of the areas over here. So again, if you're looking at these two, the ratio of their sides and the ratio of the perimeters are exactly the same once again. So these answers are going to be identical. But what we end up having to do is we have to take the ratio given to us of 25 over 36, and we have to make sure to take the square root of both of those numbers. I believe that's just 5/6. Guess what? That same exact answer should show up for the perimeters because those ratios are exactly the same as well. And again, that's from the big set of notes that I had up top for you guys earlier. Next one we've got, it says we've got some pools. They're similar rectangles. One of them is going to be 36 feet by 48 feet. We got a kiddie pool that is unfortunately just 8 feet long. Let's draw some pictures for this one. Let's do that as the real pool, kiddie pool. We have 48 feet by 36 feet. The kiddie pool is 8 feet long, and we have no clue how wide it's supposed to be. So I'm going to do just a left to right comparison here. If I compare these two values, left to right, I end up with a 48 over 8. Again, two values that I know that I have. Compare them with two values that don't really match up for us. 36 for the left, x for the right. Cross multiply. 48x. And you can do a lot of calculator work today, guys. Let's see what we got. 8 times 36. 288. I'm hoping if I divide these out, I get a nice answer. I do. The kiddie pool should be 6 feet wide. Ratio of their perimeters. You can look at these values. I have underlined these in yellow for you, but the ratio of their sides should be exactly the same as the ratio of the perimeters. So again, if you're going from the left to the right, it doesn't matter kind of which way you go as long as you label it. I should have a 48 to 8 ratio. I do just ask that you simplify those. To me, it looks like, let's just start with both of these are divisible by 4. The top one should be 12. The bottom one would be 2. And it looks like actually both of them were divisible by 8 to start. But I can divide each of those again, and it has a 6-to-1 ratio of those sides. What about their areas? Well, what we're going to do is take that ratio of 6 over 1, and we're going to square it. You should end up with a 36-to-1 ratio for the areas for that one. And that kind of makes sense for the ratios here. Just because those should match up there by times 8. Yeah, that looks really good. And 6 times, yeah, that looks really good. I like that. That would make sense here, because if you have a 6 here, 6 times 6 would give you your 36 also. Life's just feeling good. Last two. That's good news. Quadrilateral math and rock. Again, I don't care what quadrilateral you use. If I don't tell you which one to use, just draw something that's easy for you to look at. Label them in the same exact order that you guys thought. This is so hard. N-A-T-H. If I do it that way, I have to label the second one in a very similar manner. Following the same pattern. They then tell me AT is 18, OC is 30. What is the ratio of their perimeters and what is the ratio of their areas? Well, ladies and gentlemen, the ratio of their sides is equal to the ratio of their perimeters. So if I was going to go from the left side to the right side, I would end up with an 18 to 30 ratio, which we can simplify. It looks like both of those are divisible by 6. I have a 3/5 ratio of their sides, which means that's also the ratio of their perimeters. For the area, we take the perimeter / side ratio, we square them. 9/25 is what we end up with for the areas themselves. And last but not least, we again have two triangles. Let's draw them out. Label them in the same order. TAD, BIT. And it says that they have a scale factor of 3 to 2. Scale factor, and I want you to just remind yourself this, is exactly the same thing as the ratio of their sides. So it's like, hey, this triangle is twice as big, or this one says it's a 3 to 2 ratio that we have here. But they're telling us the ratio of the sides is really what they're telling us. So now they're telling us, okay, well, the perimeter of one of these shapes is this, and the area is the other. I'm sorry, it says find the perimeter if I have one perimeter of this, find the area if I have the area of that. So I'm going to start off with this. When we do this, I'm going to label a left and a right side. So if I look at this, I have a left side compared to a right side. The first ratio they gave us, it is 3 to 2. So if I look at this, I have a 3 to 2 ratio. And with this, I know that the perimeter of this, they're telling me is, I have the perimeter of TAD is 72 over here. That's a value that should go on the left-hand side. And the area of the one on the right, I don't know. Why am I using this 3/2? Because that's the ratio of their sides that they have, the scale factors that they have. So that means that should be the same exact ratio that we use for the perimeters. Hence why I'm using it here as well. We just now need to cross multiply and solve. I end up with 3x equals 144. I don't know that one off the top of my head either, but it does come out to a nice 48 for you guys. What about for the areas? Separate calculation here. But we actually have to do a little bit of work. If the ratio of their sides is 3 to 2, I know the area is that squared. So I need to end up with a 9/4 ratio for their areas. So once again, I start with the fraction that only has numerics. Just be careful of this one. They're telling you the second triangle, the one on the right, has an area of 124. Just be careful that goes in the correct place in your fractions. So I know the right side. I'm actually trying to find the area of that left side. I can now cross multiply. More calculator work. 9 times 124 gives me 1,116. I definitely don't know that one off the top of my head, but it is 279 for the area of the one on the left. Major things concept-wise to take away from this. If we were just going to run through these kind of even backwards, actually I'm going to jump to where I wrote this stuff down, which is right here. Huge reminder for you guys. This is a must know. The ratio of your sides, your perimeter, or you want to think of it as your scale factor, all of those are the same. But when you have those compared to the ratio of your area, you do need to make sure that you square them. There are problems where I might go backwards, where I give you that ratio of the area, and you have to find the perimeters. You have to then square root that ratio of the area. That's a big piece of that. Otherwise, the rest of these are really just about drawing your similar triangles, whether it is shadows, whether it is using some ratios that they gave you in these problems. But again, if you understand the concepts of all of these problems, you're going to have no issues whatsoever on the quiz tomorrow. Reminders, I will be available before school. If you guys need to come see me, just see me in the math office. Please, I highly encourage you to go see the tutoring center during your lunch period if you have questions. Otherwise, guys, I will see you tomorrow ready to go. I can probably answer a couple quick questions, 5 minutes tops in the morning before we actually get going on the quiz. So make sure you bring those ready for me. You guys have a wonderful rest of your day, and I'll see y'all tomorrow.